Welcome in Dark Core. There's something huge and massive out there deep in the universe, some unknown force that is pulling on everything and accelerating all galaxies towards the unknown, including our own Milky Way. But that's not all. Astronomers may have just found something even bigger and more mysterious. What is this unknown force, and will it destroy everything in the universe? Astronomers are very good at finding things in space, especially with the technology we have today. But this time, we have to look at something that is located outside the Milky Way, in the direction of the constellation Centaurus. On that side of the Milky Way, the disk of our galaxy, which is full of gas, dust, and stars, obscures the view from Earth. Astronomers have called this region the zone of avoidance. And something called the Great Attractor sits deep in that zone. With the development of X-ray and radio astronomy, scientists were able to look into the zone of avoidance. It turned out that our Milky Way, and the neighboring Andromeda galaxy, are moving toward the center of the local group of galaxies, which is located in the Virgo cluster. Together, they all move toward the center of the Laniakea supercluster. The attraction zone in the middle of this mega cluster is the Great Attractor. Its estimated diameter is about 300 million light-years, and its center lies about 147 million light-years away from Earth. In this area, behind the cloud of gas and dust, scientists found a large supercluster of galaxies, now known as the Norma cluster. Its total mass is estimated to be about 1,000 trillion solar masses. But later, scientists who conducted an X-ray study as part of the Clusters in the Zone of Avoidance project discovered there are far fewer galaxies in the Great Attractor region than previously thought. The Great Attractor was believed to have more than 10 million billion times the mass of the Sun. But researchers found that its mass was only 1/10 of the scientists' original estimate. Most of the visible galaxies in the region were attributed to the effect of the Malmquist bias. In space, the greater the distance, the larger the number of objects that will be too dim to detect. And so only the brightest objects could be seen. Because of this, we mistakenly associate such objects with closer regions of the sky where they do not belong. As a result, some regions of space appear to be populated by denser galaxies. So the Great Attractor may, in many ways, be a mirage showing us something that doesn't exist. It may not be a super attractor at all, but just a section of space where there are more galaxies than usual. The mass of the Great Attractor is not large enough to pull local clusters of galaxies. So what then draws them to the center of Laniakea supercluster? Looking for answers, scientists began searching for a structure with a more powerful gravitational pull and soon succeeded. This is the Shapley supercluster, a collection of approximately 20 clusters consisting of 8,000 galaxies about 650 million light-years from Earth. This supercluster encompasses 10 million billion solar masses. It's the most massive formation within a billion light-years from the Milky Way. Scanning the sky for the oldest cosmic light, ESA's Planck satellite has already taken unique images of the central part of the Shapley supercluster. The largest pink spots show the two clusters of galaxies Abell 3558 on the right and Abell 3562 on the left, as well as a couple of smaller groups between them. Scientists have also created a model of a structure located in the opposite direction from the Shapley supercluster. There, astronomers discovered a region of extremely low density, called the Dipole repeller. The Shapley supercluster pulls celestial bodies away from this region of space due to its insane gravity. As a result, the Dipole repeller is likely devoid of matter. And because underdense regions of space push matter away as much as overdense regions attract, the Dipole repeller is associated with the flow we observe too. But even the discovery of the giant supercluster Shapley has not clarified the scheme of the whole gravitational web in the area of the Great Attractor. Professor Matthew Collis of the University of Australia believes part of the Milky Way's velocity still cannot be explained. The researcher came to this conclusion by calculating the gravitational force of the Virgo cluster, the Great Attractor and the Shapley supercluster, and it doesn't add up. It turned out that our galaxy should move slower by about 50 kilometers per second, 31 miles per second. Professor Collis thinks it's due to the mysterious structures hidden behind the Milky Way. And it's possible that scientists have already found at least one of them, the Vela supercluster. It sits behind a thick blanket of dust and gas, approximately 850 million light-years from Earth. The cluster is huge. It's about 370 million light-years across and contains about 100,000 galaxies. Each of them shines with hundreds of billions of stars. If its size is confirmed, the supercluster could be the largest one in the vicinity of the Milky Way. The Vela supercluster's gravity might explain the difference between the Milky Way's actual speed and that caused by the expansion of the universe. Meanwhile, astronomers have studied 883 galaxies in the zone of avoidance, a third of which have never been observed before. The research was conducted with the Parkes radio telescope located in Australia. First, scientists were able to find 3 galaxy concentrations, Northwest 1, Northwest 2, Northwest 3, and then 2 new clusters, CW1 and CW2. On average, each galaxy contains 100 billion stars, and discovering hundreds of galaxies sitting behind our own galaxy means an incredible amount of mass scientists didn't know about. It's likely their gravity affects the speed of motion of the surrounding galaxies. But even this doesn't put an end to the mystery. The Milky Way is still moving faster than it should be. And scientists are still searching for hidden sources of gravity, as well as figuring out the nature of the Milky Way's own motion and that of other local group galaxies. One idea is that dark matter may be involved here. Its invisible clusters are just as capable of attracting galaxies with gravity as massive structures of ordinary matter. Or galaxies may be accelerated by another theoretical force of the universe, the dark flow. This is the name given to the unexpected motion of galaxy clusters, often toward an unknown mass outside the visible universe. Scientists from NASA Goddard Space Flight Center have discovered signs of this phenomenon by analyzing data from the Wilkinson Microwave Anisotropy Probe on more than 1,000 clusters. This is a very large-scale study which covers a significant part of the observable universe. The authors of the paper stated that the dark flow extends deeper into the universe than previously thought, 2.5 billion light-years from our solar system, and it heads toward the Great Attractor and then constellations Centaurus and Hydra. According to one theory, this mysterious dark flow is connected to some other world from a hypothetical multiverse. It is assumed that our universe grew out of one bubble of the primary energy field. If so, many more universes could have formed from other bubbles. And the dark flow could have been created as a result of the gravitational pull of some mass from a parallel universe. Scientists are actually considering this theory as there is an ongoing debate around it. Meanwhile, an interesting study related to the Great Attractor was conducted by an international team of astronomers. They observed the movements of 10,000 galaxies and their clusters within 350 million light-years from Earth. Scientists traced the movement of galaxies starting when the universe was just 1.5 billion years and to the present day. They calculated the trajectories of galaxies from the Milky Way based on their current brightness and position in space. Based on the results, the researchers compiled an interactive model which shows the Great Attractor, the vicinity of the Virgo cluster, and the neighboring Perseus-Pisces supercluster. The model demonstrates how clusters and individual galaxies move toward the center of attraction. But most importantly, scientists calculated the future of all these celestial bodies, including the Milky Way. They found that the accelerating expansion of the universe will keep most clusters from moving to the centers of gravity. Scientists have even compiled an interactive simulation of the trajectories of galaxies in this region in the future. The model spans an era from the early formation of galaxies to a time when the universe will be almost twice as old as it is now. The simulation shows that only a few large mergers in particularly dense clusters will occur in the next 10 billion years. For now, we know that space is one big mystery. And answers often lead to more questions. What other space anomalies would you like to hear about? Let us know in the comments. Make sure to stay tuned here for more amazing discoveries and incredible things happening in our universe. Thanks for watching Dark Core.